Okay, I am back with a new topic now. So we have conditions for equilibrium or equilibrium of rigid bodies. Now, but before that, I have to start with the condition for equilibrium of a particle. Now, so this is the condition. A particle is said to be in equilibrium if it remains at rest or originally at rest or has a constant velocity. So, if originally it is moving. But most often, no? So the term equilibrium, no, or more specifically, static equilibrium is really intended to describe, no, object really at rest. Now, so maintain equilibrium, it is necessary to satisfy the Newton's first law of motion, which requires that the resultant force acting on a particle, no, be equal to zero. And this condition may be stated mathematically as summation of forces is equal to zero. So the summation of forces is the vector sum of all forces acting into the body. So when it's when it is a particle, so it's very small. So if there are forces acting on it, no, so it is just like a concurrent force system. That is why wala tayong moment summation, no, that's included. No, so it is simply summation of forces acting on the body must be equal to zero. Now for rigid bodies, now what is considered as equilibrium? Equilibrium is a state of balance of rigid body. A body is in equilibrium condition when the resultant force acting on it is zero, including the moment. No? So as well as the resultant moment. Thus, we have conditions to follow. No? Summation of forces acting on the body is equal to zero, and the summation of moment is equal to zero. Now, to solve problem related to equilibrium of rigid bodies, no, then we have to identify the supports used, no, and have a free body diagram. No, so what's really a free body diagram or FBD, no? So it is a sketch of the outline shape of the body, isolating it from the support, no, showing all forces acting on it, including the reactions from the support. So this is a basis of analysis and formulation of equilibrium equation. And being the most important steps, no, in solving problem in mechanics, in its absence, one will find it difficult, no, to solve related problem. No, so importante ang FBD, no. So steps in constructing the free body diagram. You have to imagine the structure or body isolated from its support or surroundings, no, and you have to draw its outline shape, no. So you have to put all the forces, including couples acting on the body, reactions to the support, or point of contact with other bodies, and the weight of the body will be included. No? Then indicate the dimensions of the body needed for computing moment. So the dimensions of the body will also be indicated, no, so that the dimension can be used to find the, especially in taking moment summation, no. The magnitude and direction of unknown force must be labeled properly. So, for unknown forces, the sense of the force represented by arrow can just be started by assumption. The magnitude of the force is always positive. Thus, any negative result would mean that the assumed sense is wrong. And it is directed opposite to the assumed sense. Now, if in case mo arrive kag negative, because we know that the magnitude of the force is always plus, so it means that the assumed sense of the force is erroneous. Now, so you can have the opposite of what you assume being the correct, no, sense of your force. So, we have other related terms and condition. The term equilibrant, no? So, this is a force, no, that is equal to the resultant but opposite in direction and collinear in action. This force will help balance the forces acting on the body. So, if you have the resultant, so ang imuha karong equilibrant will be directed opposite to the resultant and is acting on the same line of action of the force. No? So, ang resultant nimo, so opposite ang imuhang sa equilibrant and it is acting on the same line of action, opposite in direction. And since you have two forces, the resultant and the equilibrant, no? So it would mean the same if you have two force equilibrium, no? So ganun man mao naman to ganina. So the two forces are said to be in equilibrium when they have the same magnitude, opposite in direction, and collinear in action. That is why the resultant and equilibrant being two forces, no? To put them into an equilibrium condition, then it should be covered under this condition. Okay, now if you have three force equilibrium, no? Three forces are said to be in equilibrium if they have a common point of intersection and their resultant is zero. If you have force equilibrium, four forces are said to be in equilibrium if the resultant of the two forces, no, paris-pariso nimo, no, you have to take a pair between two forces, take its resultant. And the resultant of the other two pair of forces will also be having the same resultant magnitude but opposite in direction, collinear in action. So, since may mo siyang two force equilibrium, so it will behave under the second condition. No? So, imo lang paris-parison ang two forces and get the respective resultant. No? So, usually when you have two forces, no, considered, no, and if you have to use a graphical method, so that is the diagonal of your parallelogram, no, which will be considered. Okay? Now, there are two types of forces acting on the body. The force which is applied, or the acting forces, which can be push or a pull, no, and reacting forces, forces exerted by supports to keep the body in equilibrium. No? So, next. For every action, there is always equal and opposite reaction. Equation of equilibrium when it is a concurrent forces. No? So, there is a summation of forces along x equal to 0, summation of forces along y equal to 0. Again, there is no moment because the forces will be acting on the same point, and if that is the case, so it will not produce any rotation effect. Now, when it is a general or parallel force system, then aside from the two, so we can add a summation of moment equal to 0. Now, we have types of reactive forces. So, tension, a force which is directed away from the body, producing a stretching effect. No? So, it will cause elongation into the body. And the other one is compression, a force that is directed, no, towards the body to produce a contracting or a shortening effect into the body. So, as illustration, so if the body is acted by these forces away from the body, so this will cause elongation. No? And we have tension for the first, and for the second, that is a condition to experience, no, for the body to experience shortening. So, the body or the forces is directed towards the body. Okay? So, again, away from the body. So, there is a pull, no, on the body causing the body to elongate. Now, most importantly also, no, because if the body is not under a balance condition, so there is a resultant, so the support is the one which will put the system into an equilibrium, no? Okay, so we have the different types of support. When it is a cable, so there is only one unknown. The reaction is the tension force, no, which acts, no, away from the cable or from the member in the direction of the cable. So if this is the member, no, so usually it is in tension, no? So that is the force which can be carried by the cable, no? So usara imong force, no, away from the member and acting along the cable, and that is always in tension. Another kind of support is a weightless link or bars, no? So this is the link, no? This is the member. So one unknown, the reaction is a force which is acting along the axis of the length, no? So for the length, it may carry tension or it may carry compression. So when that is away, so it is tension. When that is going there, that is compression. Okay, number 3, roller. So in a roller, the reaction is only one, no? And that is acting perpendicular or normal to the surface. So this is now the reaction. So this is the surface. So it is actually perpendicular. Okay, when you have a roller, no? So the unknown, the reaction is a force acting perpendicular to the surface at the point of contact. Then roller or pin, no? So the same, no? So it can be normal, no? So it can be normal, perpendicular to the slots, no? So it could be, pwede siya og away or towards, no? The member. When it is a ruler or a pen, no? In a confined small slot. Okay, so number 5, when you have a rocker, okay, still perpendicular. So there's only one force, no? Perpendicular to the surface and a point of contact. No? Then, if the surface is smooth, no? So there is also one reaction and that is a perpendicular to the surface. No? Pero dili gani siya smooth, so that's the time there is also a reaction that is along with the surface because it will develop what we call as frictional forces. No? So anon, the reaction is a force which is acting perpendicular to the surface at the point of contact. 7 is when you have a member pin connected to a collar on a small thread. Okay, so like this. So this will be normal. Okay, so smooth, no, to a collar, no. So there is a member pin connected to a collar on a small thread, no. So only one, no. So that is normal siya to the surface, no? The reaction is a force which is acting perpendicular or normal to the rod, okay, on the point of contact at the surface, no? So next is when we have smooth pen or hands, no? So there is a hands, no, or a smooth pen, because the body is prevented from moving horizontally or vertically. That is why you have two reactions, both vertical and the horizontal, or you can just have it as one. So kining usa nimo is just the resultant of these two reactive forces. Now if you reduce that into a single force, no, F, no, but if that is a smooth pen or a hands, no, so there is supposed to be vertical and horizontal. It is reduced to one when we put this as a resultant force of the two vertical and horizontal reaction. So this will serve as the components of your F. Okay? Then, okay, so I mentioned that already. You may just read. So, fixed member, no? Or member fixed. Okay, so it is fixed connected to a collar on a smooth thread. No? So, kini this is pin connected. No? So, whereas this one, and this is smooth. No? Within this one, this is fixed connected to a collar on a smooth thread. No? So, kini, this is also preventing rotation. No? So, prevent na siya og rotation. Pero kini, kinaamon ni pen, no? So, ang iha karon nga movement, so this cannot prevent rotation because this is just a pen. Pero kini, kung this is fixed, no? So, that will also prevent rotation of the body. Aside from normal, so doon na kay ngani. Okay? Doon na kay moment and moment reaction. So the two anons, the reactions are the couple moment and the force which is acting perpendicular to the rod under this case. Okay? Okay. 10. Fix. If that is a fixed support, so the body is prevented from going down horizontally and rotating. So that is why there are 3 reactions on the support. But these two again may be reduced into one, being the resultant. So it will prevent rotation and vertical and horizontal movement. Now when it is fixed. Now, so when it is fixed, usually there are 3 reactions on the support. Okay, so I think we are now ready to solve a sample problem. Okay, so that's all. And wait for the next example. Bye-bye.